Good morning to all. Today we are going to discuss about the complex analysis. In complex analysis, we are going to discuss about the complex functions of variables. Okay, it has so many applications in engineering field such as nuclear engineering, aerospace engineering, mechanical engineering, electrical engineering. In real life, complex numbers are used to measure electrical circuits and to study flow of liquids. And without complex numbers, mobile phones wouldn't exist. It has so many applications in real life as well as in engineering also. Okay, what is the complex number? Complex numbers means any number which is of the form x plus iy is called a complex number. If you observe, if x and y are real numbers, then a number is of the form x plus iy is known as complex number. It is denoted by z. We can write it as z equal to x plus iy. Here x and y are the real numbers. Any number we can represent in this form, x plus iy form. This is called a complex number. Here I is called the imaginary unit. We can write it I equal to square root of minus 1. In this complex number, x is the real part of z. We can write as re of z. Y is called imaginary part of z. It can be written as Im of z. Suppose x equal to 0, then z becomes Iy. So that means what? There is no real part. So z is called a purely imaginary number. Suppose y equal to 0, then z becomes z equal to x. Z equal to x is called a purely real number. There is no imaginary value. The complex conjugate of z is represented as z bar, defined as x minus iy. We can represent complex numbers in geometrically also. We know the xy plane. If you observe the xy plane, x and y represent z equal to x plus iy is an order pair x comma y. Here x axis called a real axis and y axis is called a imaginary axis. So this plane, this xy plane is called a complex plane or Argand's plane. We represent z equal to x plus iy in a two-dimensional coordinate system is called a complex plane or Argand's plane. X-axis is called a real axis and y-axis is called imaginary axis. Properties. Suppose take z equal to x plus iy, then its conjugate is z bar equal to x minus iy. Now, yeah, as a real number system, we can apply the addition, subtraction, multiplication, and division. Similar manner, it has same type of the properties. Addition of two complex numbers, subtraction of two complex numbers, multiplication of two complex numbers, ratio of complex numbers, like that. Okay. Suppose first one, z plus z bar equal to 2x. Z plus z bar equal to 2x means adding complex number and its conjugate, that is 2x. Z minus z bar equal to 2iy. Subtracting complex and its conjugate, that is 2iy. Multiply z bar. Z is x plus iy. Z bar is x minus iy. Multiplying, this is of the form a plus b into a minus b, a square minus b square, that will be x square plus y square. Z by z bar, x plus iy by x minus iy. Rationalizing, then numerator part becomes x plus iy whole square, a plus b whole square form. Denominator a plus b into a minus b form. Simplifying, then x square minus y square by x square plus y square is the real part, plus 2xy by x square plus y square is the imaginary part. Next, modulus z square represented as z into z bar. Z into z bar already we have calculated, that is x square plus y square. That means z bar and modulus z square value both are same, that will be x square plus y square. Polar form of a complex number. So z equal to x plus iy is a complex number in Cartesian form. So we can represent this complex number in polar coordinates also. We know the relation between Cartesian and polar, that is x equal to r cos theta, y equal to r sin theta. Substituting these two values in x plus iy, we have r cos theta plus ir sin theta. Taking r common, cos theta plus I sin theta. By Euler's formula, we can write it as e power I theta, or e power I theta, or you can write it as r. C means cos, I imaginary value, S is the sin theta. We can write r cis theta or r e power I theta. This form is called a polar form or mod amplitude form of a Z, where r equal to square root of x square plus y square, theta equal to tan inverse y by x. So why should we are calling mod amplitude form of Z? So here r equal to square root of x square plus y square. This is called a modulus of Z. Theta is called a amplitude of Z. So we are representing Z value in terms of the r and theta. That means modulus value and amplitude value. So this is called a mod amplitude form of a Z. Next, complex function. Take the two complex variables. Let z and w, z equal to x plus iy, w equal to u plus iv are two complex variables. If to each value of z there corresponds a one or more values of w, then w is called complex function of z. It is denoted by w equal to f of z. That means giving different values of z, if you get one or more values of w, then w is called a complex function. It is denoted by w equal to f of z. So to each value of z, one or more values. Suppose to each value of z, only one value of w exists, that function is called single valued function. Suppose to each value of z, more than one value of w exists, that is called a multiple valued function. That means complex function is divided into two. One is single valued function, other one is the multiple valued function. W is u plus iv, z is x plus iy. So f of x plus iy. If you equating these two values, then here u is the real part, v is the imaginary part. So u is a function of x and y, v is a function of x and y. Observe the problem. Let us see the problem. If w equal to f of z equal to z square plus z, find its real and imaginary parts. Also find f of z at 1 plus I. So function is given. We need to find the real and imaginary parts. And also we have to find f of z value at 1 plus I. Take the given function w equal to z square plus z. Substituting z value x plus iy whole square plus x plus iy. Use a plus b whole square form. X square, iy whole square means minus y square. 2ab, 2ixy plus x plus iy. Separating the real and imaginary parts. X square minus y square and x plus from the 2ixy plus iy taking I common 2xy plus y. Equating with u plus iv, equating the values right hand side and left hand side, then real part is u, here real part is x square minus y square plus x. So this is real part of f of z, and imaginary part on left hand side is v and the right hand side is 2xy plus y. This is imaginary part of f of z. So we have calculated real and imaginary parts of the given function. Next, we need to find f of z value at 1 plus I. What is f of z value? F of z is x square minus y square plus x plus I 2xy plus y. In this, substituting the point 1 plus I. 1 plus I represented as an order pair, that is 1 comma 1. X value 1, y value 1. Substituting 1 square minus 1 square plus 1. 1 cancel, only 1 exists. Here x1, y1, 2 into 1, 2 plus 1, 3i. 1 plus 3i. F of z value at 1 plus I is 1 plus 3i.